when you tap Buy Now on your phone, um, a highly complex, almost invisible clockwork violently springs into action, right? All to ensure a box appears on your porch 48 hours later.
Yeah, it really is staggering when you look at the mechanics of it.
It is. And today, we're basically tearing the face off that clock.
Wow.
We're doing a deep dive into the hidden machinery of planning operations. We're pulling directly from the APICS Certified Supply Chain Professional Learning System, specifically Module 4, Section A.
Right, which is a fantastic source for this.
Yeah, it is. And our mission today is to figure out the exact mechanisms companies use to balance like massive scales of supply and demand, without drowning in unsold inventory or leaving you with that dreaded out-of-stock notification.
Which is really the ultimate balancing act, because the challenge there is moving from a broad, high-level business goal down to the incredibly unforgiving reality of factory floor execution. It's a deeply mathematical journey.
High-level business planning always reminds me of standing in the kitchen on New Year's Eve and declaring, I'm going to eat healthier this year.
Right, a classic.
Yeah, it's a great vision, right? But planning operations is the gritty reality of actually writing the exact grocery list, checking your pantry to see if you actually have olive oil, and timing when to put the chicken in the oven so it finishes at the identical moment the rice is done.
Exactly, because a vision without a timed execution plan is, well, it's just a wish.
Right.
In a manufacturing environment, translating that wish into reality begins with a process called master scheduling. This is really where the broad strokes meet the fine details.
Okay, so the APICS material really emphasizes taking aggregate data and breaking it down.
Yeah.
So if we look at a technology company manufacturing laser printers, the executive team might look at market trends and forecast a need for, say, 1,000 laser printers for the upcoming month.
Yes, but that is an aggregate number for an entire product family.
Just a big bucket number.
Exactly. And a factory floor cannot simply build 1,000 printers. The assembly line needs specific instructions for specific models, and this is the domain of the master scheduler.
All right.
Their whole job is to disaggregate that high-level number. They take that 1,000 and slice it into actionable units tied to specific dates.
So getting granular with it.
Right. So the schedule might dictate 50 units of the high-end 30-page per minute LX30 models in week 1, followed by 75 of the mid-range models in week 2. The resulting document from all this is the Master Production Schedule, or the MPS.
And looking at how this operates, the MPS basically functions as a firm contract, right? Like between the sales force and the operations team.
It absolutely is a contract.
Yeah, so sales guarantees they will sell these specific units if operations builds them, and operations guarantees they will have those specific units ready on those exact dates.
Precisely. And this contract is crucial because it prevents sales from making, impossible delivery promises to clients. And at the same time, it stops the factory from blindly guessing what to build and ending up with a warehouse just full of obsolete printers.
Which nobody wants.
Nobody wants that. So to manage this delicate agreement, the system utilizes what are called time fences on the master scheduling grid.
Time fences. Right.
Yeah, they're essentially rules dictating how easily a schedule can be altered as the actual production date looms closer.
And the source breaks this down into 3 zones, which I found fascinating. The furthest out is the liquid zone, which sits beyond the planning time fence.
Right.
And in the liquid zone, the schedule is highly adaptable. If changes need to be made months in advance, the supply chain has, ample runway to adjust course. Right?
Exactly. It's fluid, hence liquid. But time constantly moves forward. As we get closer to the production date, we cross that planning time fence and enter what is called the slushy zone.
The slushy zone. I love that term.
It's very descriptive. Here, materials for the printers might be ordered from suppliers, but they haven't necessarily been cut, dyed, or assembled yet.
So you're committed, but not totally locked in.
Right. There is still some room to negotiate trade-offs. Like if the sales team desperately needs to swap one printer model for another, the master scheduler has the authority to make the call. But it almost always requires giving something else up in the schedule to maintain balance.
You can't just add without subtracting.
Exactly. And then we cross the demand time fence, and the schedule enters the frozen zone.
Right, the frozen zone.
Yeah. The materials are fully committed, the assembly line is prepped, and the schedule is, as they say, locked in ice.
Okay, so I have to push back on this concept of absolute rigidity.
Let's hear it.
Let's assume I'm a senior salesperson, right? My absolute biggest, most lucrative VIP client calls me in a total panic. They urgently need to change an order, and the production date happens to sit squarely inside this frozen zone.
Oh, the classic scenario.
Right. Does the system seriously just reject the request? Because, I mean, the customer is supposedly always right.
This specific scenario causes eternal tension in boardrooms everywhere, I guarantee you. But yes, the master scheduler has to hold the line and reject that request, or at the very least, require sign-off from the absolute highest levels of senior management.
Wait, really? Even for a VIP?
Even for a VIP, because shattering the ice of the frozen zone carries massive, cascading direct costs.
See, I would assume it's just, paying the assembly team a little overtime to stay late and swap the parts out. What's the big deal?
I mean, I wish it were that simple. The fallout goes so much further than just a few hours of overtime. The entire factory floor has to be rescheduled.
Oh, wow.
Yeah. You might have to pay exorbitant expedite fees to your suppliers to rush new microchips or plastic casings on a private jet. You may have to literally throw away materials that were already customized or cut for the original production run.
Just totally scrapped.
Totally scrapped. And even worse, bumping your VIP order to the front of the line inherently delays the schedules for every other item on the floor.
Oh, so you're messing up everyone else's orders.
Exactly. You risk infuriating 5 reliable customers just to appease one VIP. So the frozen zone exists solely to protect the efficiency and profitability of the entire manufacturing network.
Okay, when you put it like that, respecting the frozen zone makes total sense from a production standpoint. Operations has a locked schedule they can confidently execute.
Right.
But this creates a new problem for the front lines, doesn't it? Because the sales team is out there closing deals and shaking hands. How do they know what inventory they can actually leverage to close a deal without accidentally promising the exact same batch of laser printers to 2 different corporate clients?
That is the million-dollar question, and they rely on a calculation called available to promise, or ATP. Yeah, this represents the uncommitted portion of a company's inventory and planned production. It is the exact pool of product that sales can actively draw from to guarantee a delivery date to a new customer.
Okay, and the distinction the APCS text makes here is fascinating. It aggressively separates available to promise from something called projected available balance, or PA.
Yes, and the separation of those two metrics is absolutely vital.
Right.
Projected available balance is simply the running mathematical sum of the physical inventory you expect to have in the warehouse on any given future date.
So it's literally just what's in the building.
Exactly. It's calculated by taking your current on-hand inventory, subtracting what you expect to consume, and adding what the master schedule says will be built. It is purely a physical reality check of what will be sitting on the shelves.
Okay, so this is like looking at my checking account app on a Friday morning and seeing a balance of $1,000. The bank confirms that physically the $1,000 is sitting there. That is the projected available balance.
Perfect analogy, yes.
Yeah. But the available to promise is me looking at that screen and realizing, $800 of that balance is already earmarked for rent and groceries that will automatically deduct on Monday.
Right.
So my actual available to promise for, say, taking a spontaneous weekend road trip is only $200.
Exactly. If your sales team looks at the $1,000 P and promises the full amount to a new client, your metaphorical rent check is going to bounce.
It's a disaster.
Total disaster. So ATP isolates exactly what is free, clear, and unencumbered. And the math becomes even more nuanced when we factor in the nature of the product itself. Specifically, the difference between perishable and non-perishable goods.
Oh, right.
Yeah.
Because if the product is milk or beer or pharmaceuticals, the clock is actively ticking the moment it rolls off the line. I'd imagine you can't just let unsold inventory roll over month to month in the system.
You absolutely cannot. For a perishable product with a strict expiration date, the supply chain software must use a non-cumulative or discrete method to calculate ATP.
Discrete method.
Yeah, so if you have a surplus of milk in week 1, the system cannot carry that surplus forward to promise to a new customer in week 4.
Because by week 4, the product is completely spoiled.
Exactly. The calculation rigidly isolates the available to promise for perishables strictly within their viable, unexpired time periods.
That makes total sense.
Yeah.
So we have the ATP calculated. The sales team has secured the orders based on real data, and the master schedule dictates exactly what finished products we are making and when.
Everything is looking good.
Yeah, but a schedule is just a piece of paper, right? The factory floor needs the actual physical ingredients, the plastic, the microchips, the glass, to actually build the printers.
And that brings us to the real engine room of supply chain logic, which is material requirements planning, or MRP.
MRP.
Yeah, this is the ultimate calculator for coordinating raw materials.
Hmm.
But to grasp how MRP operates, we first have to establish the fundamental difference between independent demand and dependent demand.
Right, and the APICS learning system uses blue jeans to illustrate this, which I think clarifies the concept perfectly.
It's a great example.
Yeah, so independent demand is the demand coming directly from the consumer. We have to forecast that, say, next month, consumers will walk into stores and independently demand 1,000 pairs of finished blue jeans.
Exactly.
And it requires educated guessing, right, based on historical trends, seasonal shifts, maybe marketing campaigns.
Right, it's always a bit of a guess.
Yeah.
But dependent demand requires absolutely zero guessing. It is purely mathematical.
Right.
It is derived directly from the independent demand we placed in the master schedule. If the schedule commits to building 1,000 pairs of jeans, the system calculates a dependent demand for exactly 1,000 left legs, 1,000 right legs, 2,000 front pockets, and 1,000 zippers.
I just love that. You don't need a crystal ball for zippers. You just need a calculator and the exact recipe for the product.
And that recipe is called the Bill of Materials, or the BOOM. It is a deeply layered, multi-level product tree detailing every single component.
Every thread, every button.
Every single one. So MRP takes the master production schedule, cross-references it with your current inventory levels, and feeds it all through the Bill of Materials.
Just crunches the numbers.
Right. And the output is a massive list of planned orders for every single raw material, but it doesn't just calculate how many zippers or yards of denim you need. It calculates exactly when you need to order them through a process known as offsetting.
Oh, offsetting. This is where the chicken and the rice timing comes into play.
Precisely. Offsetting counts backward from the final production due date to accommodate the vastly different lead times of your raw materials.
Okay, so let's apply that to the blue jeans.
Yeah, let's do it. Assume the denim fabric takes 3 weeks to arrive from an overseas supplier, but the standard metal zippers can be sourced locally in just 1 week.
Okay.
If production is scheduled for week 4, offsetting commands the system to release the purchase order for the denim in week 1, but deliberately delays ordering the zippers until week 3.
So the bulky rolls of denim and the boxes of zippers arrive at the cutting tables perfectly simultaneously, just in time for the assembly line to fire up.
Exactly.
It's incredibly elegant when it works. But the text warns about something called system nervousness, which sounds like what happens when a planner tries to manually outsmart this math.
Yes. System nervousness is the absolute nightmare scenario for an MRP environment.
Nightmare scenario.
Oh, yeah. Because MRP is a highly interconnected web of fixed lead times and dependent calculations, it requires stability. If a planner makes frequent reactive adjustments, perhaps constantly tweaking the master schedule to chase, like daily fluctuations in sales, it triggers a massive ripple effect.
Oh, I see.
Yeah, changing the due date of the finished blue jeans by just 3 days forces the software to entirely recalculate and reschedule the purchase orders for the zippers, the pockets, the denim, and the dye.
So it just creates a domino effect of administrative chaos.
It paralyzes the organization. The purchasing department gets flooded with thousands of automated system messages instructing them to expedite an order they placed yesterday or cancel a shipment they just paid extra to rush.
Which is just going to drive everyone crazy.
Exactly. The staff quickly loses all faith in the system's recommendations. And this highlights exactly why those time fences we discussed earlier, the frozen and slushy zones, are so critical.
Right, they act as a dam.
Yes, keeping the daily volatility of consumer whims from flooding the MRP system and triggering that system nervousness.
Okay, so let's assume the dam holds. We planned the raw materials perfectly, avoided system nervousness, and successfully manufactured the 1,000 pairs of jeans using MRP.
Mission accomplished on the floor.
Right. They are boxed up, sitting on pallets in the central factory warehouse. But, finished jeans sitting in a dark warehouse don't generate any revenue. They need to get to the retail stores or regional distribution centers where consumers can actually buy them.
Which brings us to distribution. It's the final hurdle. The framework that manages this is Distribution Requirements Planning, or DRP.
DRP.
Right. It serves as the mathematical bridge connecting the centralized factory to the decentralized front lines. And really, the entire concept of DRP was born out of the historic failures of the two traditional extremes of inventory distribution: push systems and pull systems.
Okay, well, a push system sounds like corporate headquarters calling all the shots.
It is highly centralized. The decisions are made at the manufacturing site or the corporate level. Analysts look at the overall national forecast and literally push the inventory down the chain to the distribution centers and retail stores based on their broad calculations.
And from the factory's perspective, I guess that makes logistical sense. You can coordinate massive, cost-effective freight shipments and keep the loading docks running smoothly.
It's very efficient at the top.
But it seems entirely blind to local market realities. I mean, if corporate pushes identical shipments of heavy winter coats across the entire country based on a national average, the retail stores in Miami are going to be buried in inventory they cannot possibly sell.
And that lack of local responsiveness is the fatal flaw of a pure push system.
Right.
So the logical countermeasure is a pull system. This approach flips the power dynamic to be entirely decentralized.
Okay.
The local branch managers and retail stores make their own inventory decisions. They monitor what is actually selling on their specific shelves, and they pull inventory from the central warehouse only when they physically need to replenish it.
See, I am going to advocate for the pull system here.
Oh, really?
Yeah. If you are running a local hardware store in a small town, you inherently understand your specific town's buying habits far better than, like, a corporate executive sitting in a skyscraper 1,000 miles away. Giving the local level total autonomy to pull exactly what they need seems like the most efficient way to prevent wasted inventory.
It seems absolutely bulletproof on paper, I'll give you that. However, relying purely on a pull system creates a devastating supply chain phenomenon known as the bullwhip effect.
The bullwhip effect.
Yeah.
Okay, how does local autonomy trigger a bullwhip?
Well, think about the physical mechanics of holding a long whip. If you give your wrist a tiny little flick at the handle, that small wave travels down the leather, amplifying and gaining energy as it goes, until the very tip violently snaps.
Right, a huge reaction at the end.
The identical physical reaction happens with order quantities in a disconnected supply chain. Imagine a winter storm is forecasted, and that local hardware store manager sells 3 more snow shovels than usual this week.
Okay, just 3 shovels.
Right. But just to build in a little safety buffer, they decide to order 5 extra shovels from the regional distributor.
Which, honestly, adding a buffer of 2 extra shovels makes total sense for a local manager trying to avoid an empty shelf.
It completely makes sense. But then the regional distributor receives orders from 50 different hardware stores in the state, all slightly inflated by their own tiny safety buffers.
Oh, no.
Yeah. The distributor looks at this aggregate data, gets spooked by what looks like a sudden, massive spike in demand, and decides to order an extra 500 shovels from the central corporate warehouse just to be safe.
So the wave is getting much bigger.
Way bigger. The central warehouse sees an unprecedented spike in orders from the regional distributors, panics entirely, and commands the manufacturing plant to immediately double the production of snow shovels.
That's insane.
A tiny, completely normal blip in local consumer demand has been amplified by fear and a lack of visibility into massive, incredibly costly inventory distortions at the factory level.
Wow. So a pure pull system blinds the factory to reality, while a pure push system ignores the local customer completely. We need a system that somehow extracts the benefits of both without triggering a bullwhip.
And this is exactly what distribution requirements planning was designed to do. DRP is the hybrid solution. It takes the local, hyper-accurate responsiveness of a pull system and integrates it with the coordinated, heavily optimized logistics of a push system.
But how does the actual math blend them together without, losing the local data?
DRP gathers all of the decentralized demand from the local distribution centers, incorporating what they actually need based on their local forecasts and their required safety stock. But instead of the factory just blindly reacting to those raw, panicked orders, DRP runs them through a filter.
A filter?
Yes. It translates the local needs into what supply chain professionals call time-phased net requirements.
Okay, we need to break down that jargon. What exactly is a net requirement in this context?
Let's use our hardware store. The local store forecasts they will sell 50 shovels next month. That is their total need. But the DRP system looks at the store's backroom and sees they already have 10 shovels sitting in inventory.
Okay.
The net requirement, what they actually need to acquire to hit their target, is only 40 shovels.
So it just subtracts what you already have from what you ultimately need to prevent you from overordering out of panic.
Exactly that. DRP calculates these clean, realistic net requirements for every single local branch. It then sends those numbers up the chain and aggregates them. The factory gathers all of these refined local numbers and consolidates them into their gross requirement.
Fun.
This becomes the massive overarching number plugged directly into the factory's master production schedule.
Wow, it totally bridges the gap. The corporate level gets a massive, clean aggregate number so they can optimize their assembly lines and freight shipments, the benefits of push.
Right.
But that large number is built entirely on the granular, highly accurate, panic-free data pulled from the local level. It completely neutralizes the bullwhip effect.
It really does. It allows the entire supply chain to breathe and move as a single organism rather than a series of disconnected, panicking nodes.
That is just brilliant. Okay, let's retrace the steps of this entire machine. We have seen how supply chain planning begins with translating a high-level corporate vision into a highly specific, zone-protected master production schedule.
Yep, starting with the schedule.
We explored how the sales force uses the available-to-promise calculation, especially those strict rules for perishable goods, to guarantee they aren't writing checks the factory floor cannot cash.
Exactly.
We mapped out the logic of material requirements planning, relying on dependent demand and precise offsetting to ensure raw materials arrive exactly when needed. And finally, we unpacked how distribution requirements planning tames the bullwhip effect by turning chaotic, local pulls into a clean, highly optimized push.
And the key takeaway is that every single phase relies entirely on the mathematical discipline and accuracy of the phase before it. If one gear slips, the entire mechanism grinds to a halt.
It is a relentless, invisible symphony of calculations operating behind the scenes 24 hours a day. And, the next time you, the person listening to this right now, buy a complex product, whether you are ordering a custom computer, a pair of jeans, or just picking up a laser printer and it arrives flawlessly on schedule, take a moment to appreciate the master schedulers, the MRP offsets, and the rigid time fences that made it possible.
A staggering amount of engineering is required to make a modern transaction feel like magic.
It really is magic.
Yeah.
But I want to leave you with a final scenario to consider on your own. We have spent this entire deep dive exploring how these operations rely on fixed lead times, historical forecasts, and strict mathematical rules.
Very strict rules.
Right. And everything works perfectly when reality obeys the math. But what happens to this highly optimized, tightly wound clockwork when an unpredictable black swan event occurs?
Oh, boy.
Yeah. What happens when a sudden global health shutdown closes 50 ports overnight? Or a massive cargo ship gets blown sideways and completely severs one of the world's major shipping canals? When reality shatters the ice of a mathematically perfect frozen zone, how does a system built entirely on rules adapt to pure chaos?
That is the moment a supply chain stops being an algorithm and becomes a test of human resilience.
Definitely something to think about the next time a package arrives a day late. Until next time, keep diving deep.